Let's take a look at graphing functions of the form y equals sine x minus c and y equal cosine x minus c. In these forms, c shifts your graphs horizontally to the right or the left. Let's look at our basic cosine curve. We know what it looks like. The period is 0 to 2 pi. So if c is positive, it's going to take our graph and shift it to the right c units. So the first x-coordinate of the quarter point in this case would be c, and then the last x-coordinate would be c plus 2 pi. If c is negative, you're going to shift to the left, and so your first x-coordinate of your quarter point will be c, and again, the period's 2 pi, so the last x-coordinate will be c plus 2 pi. Let's look at an example. Let's look at y equals sine x minus pi over 2. Well, we know what our basic sine curve looks like. I've listed the quarter points for y equals sine x. So here, remember the amplitude is going to be the absolute value of a, which is 1 in this case, so the amplitude is 1, and the period is 2 pi over b, and notice in this case b is 1, so the period is still 2 pi. But the graph is going to be shifted pi over 2 to the right, so that means that the first x-coordinate of the quarter point is going to be pi over 2. So let's figure out all the x-coordinates. So since the period is 2 pi, 1/4 of that period is pi over 2. That's going to represent the interval between each x-coordinate. So what we're going to do is we're going to add pi over 2 to each of these x-coordinates to get our next x-coordinate. Pi over 2 and pi over 2 is pi. Pi plus pi over 2 is 3 pi over 2. 3 pi over 2 plus pi over 2 is 2 pi. And 2 pi plus pi over 2 would be 5 pi over 2. So again, all we're doing is we're adding 1/4 of the period to get these x-coordinates. Now the y-coordinates haven't changed at all, so we're going to have pi over 2, 0, pi 1, 3 pi over 2, 0, 2 pi negative 1, 5 pi over 2, 0. So the graph is going to look like this. Pi over 2. So let's see, pi over 2, 0, pi 1, 3 pi over 2, 0, 2 pi negative 1, 5 pi over 2, back to 0. Okay, here we've drawn one cycle or period for this function, and of course the domain's all real numbers, so it's going to continue in both directions. Let's look at sketching graphs of functions of the form y equal a sine bx minus c and y equal a cosine bx minus c. I've listed the characteristics of the graphs here in this box, and I want to show you why the period is 2 pi over b and the phase shift is c over b. The first thing I want to talk about is b. You need to make sure that b, the coefficient of x, is positive first. If it's not, you're going to rewrite the function using even-odd properties to make b positive. So let's also remember, if you recall, when you're graphing y equal a sine x and y equal a cosine x, recall that the period for those graphs is 2 pi, so that means they complete one cycle when x is between 0 and 2 pi. Well, graphs in either one of these forms will complete one cycle when bx minus c is between 0 and 2 pi. So let's set that up. So we have bx minus c between 0 and 2 pi, and we've made b positive, remember, by even-odd properties if we need to. Now we're going to solve this for x. So let's add c to both sides. And divide by b. So what we can see here is that graphs in either one of those forms are going to complete one cycle when x is on the interval c over b to 2 pi over b plus c over b. That's when it will complete one cycle. Well, the length of that cycle is the period. So the period is going to be when you take 2 pi over b plus c over b. If you subtract c over b, we can see that we get 2 pi over b. So the period is 2 pi over b. And we can see here that this expression right here is the phase shift. Remember, the first quarter point of those functions used to start at 0. Now it's going to start at c over b. So we call c over b the phase shift. So the phase shift is c over b, period is 2 pi over b, amplitude is absolute value of a, and the range is negative absolute value of a to the positive absolute value of a. Let's look at an example. Here I want to sketch the graph of y equal 4 cosine 2x plus pi. Now, I need to figure out what's the amplitude. Well, remember the amplitude is the absolute value of a, which in this case is 4. The range then is going to be negative 4 to 4. The period is going to be 2 pi over b. Okay, let's look in this example. What's b? Notice that b is positive. b is 2. Oops, 2. Sorry about that. 2 pi over 2. So the period for this graph is pi. And what's the phase shift? Well, the phase shift is going to be c over b. Now notice that I see a plus sign. If you like, you can actually factor out the 2. If I factor out the 2, I'm going to have x minus a pi over 2. Whoops, I need a 2 minus a negative. There we go. So I'm just changing the plus sign to subtracting. So this is x minus, I can see here, this is my phase shift. Okay. Some students like to factor out the b. Some students just like to use the formulas, whichever works for you. So I know that the period is pi and the phase shift is, we said c was a negative pi over 2. So the phase shift is negative pi over 2. Okay, so now we need to figure out the quarter points for this graph. Well, I've listed the quarter points for y equal cosine x. B and C are going to change the x coordinates of those quarter points. So remember, it used to start at 0. Well, now it's going to start at the phase shift, which is negative pi over 2. Now, how do I get the next x coordinate? Remember how to do that? You take 1/4 of the period. Well, 1/4 of the period is just pi over 4. So I want to be adding pi over 4 to each of these x coordinates. Well, negative pi over 2 is negative 2 pi over 4. If you add pi over 4, you're going to get negative pi over 4. And again, add pi over 4 to negative pi over 4, you get 0. Add pi over 4 to 0, you get pi over 4. And lastly, add pi over 4 to pi over 4, you get 2 pi over 4, which is pi over 2. So now we found all the x coordinates. How do we find the y coordinates? Well, the y coordinates are found by taking the y coordinates of these quarter points and multiplying by a, which in this case is 4. So let's see, 1 times 4 is 4. 0 times 4 is 0. Negative 1 times 4, negative 4. 0 times 4 is still 0, and then 1 times 4 is 4. So now we found our quarter points. We can plot those points. So let's see, negative pi over 2. And then I need 4 and negative 4. And so we have negative pi over 2, 4, 0, negative 4, 0, back up to 4. All right, so here's one cycle for this particular function. And of course, the domains are real numbers, so it's going to keep going in either direction. Let's look at another example. In the previous example, we had y equal 4 cosine 2x plus pi. We can rewrite this as 2x minus a negative pi so that we can see the a is 4, the b is 2, and the c is negative pi. Well, in our next example, y equal 2 sine negative 4x plus pi, we need to rewrite it for a different region. Let's write down this function. We have 2 sine negative 4x plus pi. Well, I see a plus sign here and I see a plus sign here, but it turns out the phase shift is not negative because, more importantly, I have b that's negative. And whenever b is negative, your first step is to rewrite it using even-odd identities. If you recall, the sign is odd, which means what? It means the sign of negative x is negative sine x. So what I can do is I can factor that negative out, and then I actually have 4x minus pi. And then using even-odd identities, this is equal to negative 2 sine of 4x minus pi. So now I can see that my a is negative 2, my b is 4, and my c is pi. So now let's figure out the amplitude. Well, the amplitude is going to be the absolute value of a, which absolute value of negative 2 is 2. The range is going to be negative 2 to 2, period. It's going to be 2 pi over b. My b, remember, is 4. So that's pi over 2. And my phase shift is c over b. So it's positive this time. Okay, so now look at, we have the quarter points for y equals sine x. We know what those are. You should know those very well. So how do we get the quarter points here? Well, the x-coordinates, the first x-coordinate starts at your phase shift. So pi over 4 is the first x-coordinate. Now how do we get the next one? Do you remember? Exactly. You have to take 1/4 of the period, which is pi over 8. So this time I want to add pi over 8 to each of the x-coordinates. So let's see, pi over 4 is the same thing as 2 pi over 8. Plus pi over 8 gives you 3 pi over 8. 3 pi over 8 plus pi over 8 is 4 pi over 8, which reduces to pi over 2. 4 pi over 8 plus pi over 8 is 5 pi over 8. And last x-coordinate, 5 pi over 8 plus pi over 8 gives you 6 pi over 8, which reduces to 3 pi over 4. Okay, now how do we get the y-coordinates? Remember, to get the y-coordinates, you multiply these y-coordinates by a. And be careful, remember a is negative 2. So 0 times negative 2 is still 0. 1 times negative 2. 0 times negative 2. Negative 1 times negative 2. And 0 times negative 2. So now we can plot these points. Let's see. Let's make this pi over 8. So pi over 4 here. 3 pi over 8. Pi over 2. And 3 pi over 4. And then we have... Okay, so our first point, pi over 4 is 0. And then it's decreasing first. So 3 pi over 8, negative 2, back to 0, 2, back to 0. And of course, since we have one cycle, we can continue this graph in either direction. It's going to just continue the graph. So remember, very important when b is negative that you rewrite it first to get b positive. Let's look at sketching graphs of functions of the form y equal a sine bx minus c plus d and y equal a cosine bx minus c plus d. You may recall from algebra that when you add a constant to a function, it shifts the graph vertically. Same thing's going to happen here. So remember your quarter points for a sine bx minus c. Well, all you're going to do, you're going to add d to the y coordinates of all the quarter points of this function. Or of course, if it's a cosine, you're going to add d to all the quarter points of a cosine bx minus c. Now, remember we're shifting vertically, so that's actually going to change the range. Remember the range, when we don't have a d, when d is 0, is negative absolute value of a to a. So to get the range for functions in this form, we have to add d to get the range. We have to do negative absolute value of A plus D, so you're adding D to all the y coordinates to absolute value of A plus D. Period and phase shift do not change. Let's look at an example. I have y equal 3 cosine 6x minus pi plus 2. So here I can see that A is 3, so I know my amplitude is 3. Absolute value of 3 is 3. But what's the range? Well, remember the range is going to be negative 3, and then we have to add 2 to positive 3 plus 2, so the range is negative 1 to 5. The period is going to be 2 pi over b. Okay, so my b is 6, my c is pi, and my d is 2. So let's see, 2 pi over 6. My period is going to be pi over 3. And my phase shift is going to be c over b, so pi over 6. Now, I've listed the quarter points for y equal cosine x. Let's get the quarter points for this function. The first x coordinate is your phase shift, so pi over 6. Now, remember what you add to each of these quarter points. We need to find 1/4 of the period. 1/4 of pi over 3 is pi over 12. So what I want to add to each of these x coordinates is pi over 12. Think of pi over 6 as 2 pi over 12. When you add pi over 12 to 2 pi over 12, you get 3 pi over 12, which reduces to pi over 4. 3 pi over 12 plus pi over 12 is 4 pi over 12, which reduces to pi over 3. And 4 pi over 12 plus pi over 12 is 5 pi over 12. And then 5 pi over 12 plus pi over 12 gives me 6 pi over 12, which reduces to pi over 2. So notice that my x coordinates are affected by b and c. Now we need to get the y coordinates. Well, remember, when we didn't have a d, we got the y coordinates by multiplying my y coordinates by a. Well, now we multiply our y coordinates by a, but then we add 2. So let's go. A is 3, so we're going to do 1 times 3 is 3, plus 2 gives me 5. 0 times 3 is 0, plus 2 is 2. Negative 1 times 3 is negative 3, plus 2 is negative 1. 0 times 3 is 0, plus 2 is 2. And finally, 1 times 3 is 3, plus 2 is 5. So let's plot these quarter points. And let's see, I need to go up to 5. And down to negative 1. Okay, so we have pi over 6, we're up at 5. Pi over 4, we're at 2. Pi over 3, we're down at negative 1. Back to 2. And back to 5. All right. So here's one cycle for this function. And of course, domain is all real numbers, so it doesn't stop. It continues in both directions forever. So I want to reiterate. To get your x coordinates, you find the phase shift, then you add 1/4 of the period. To get your y coordinates, you multiply the old y coordinates by a, and then you add d. Suppose we want to determine the equation of a function given the graph. Look at this graph. Suppose we were asked to choose an equation of a function from this list below that matches this graph. Take a minute and you'll realize that all 5 of these equations match this graph. So we're going to have to know more information in order to determine a unique function. Let's look at this example here. We're given the graph and we want to determine the equation of a function of the form, and we're going to be told it's a cosine curve, and we're going to be told b is positive. And also we're going to associate these 5 labeled quarter points with the 5 quarter points for y equal cosine x over the interval 0 to 2 pi. Well, let's write those quarter points down. We should know what they are. For y cosine x, those quarter points are 0, 1, pi over 2, 0, pi, negative 1, 3 pi over 2, 0, 2 pi, 1, and we can see the quarter points for this one. Pi over 6, negative 4, pi over 3, 0, pi over 2, 4, 2 pi over 3, 0, and 5 pi over 6, negative 4. So this quarter point is associated with this one and so on. So what this tells me, I can see that the phase shift is pi over 6. Also, we can figure out the period because the first quarter point is pi over 6. Well, the first x-coordinate of the quarter point is pi over 6, and the x-coordinate of the last quarter point is 5 pi over 6. The difference between those two x-coordinates gives us the period, so we can figure out the period. We can take 5 pi over 6 and subtract pi over 6 to get 4 pi over 6. And reduce that, that's 2 pi over 3, so I know what my period is. Now, do you remember how to find the period? Exactly, so to get the period, you take 2 pi and divide by b. Remember, we're assuming b is positive this time. So we can easily see that in this case, b is 3. Okay, so now we know b. We want to come up with c and a. Well, remember, we know the phase shift is pi over 6. And remember, to get the phase shift, you take c over b. So I know c over b is pi over 6. And we just found that b was 3, so we know c over 3 is pi over 6. We can solve this for c. So c is going to be 3 pi divided by 6, which is pi over 2. So we know b, we know c, we need to find a. Well, looking at this graph, we can easily determine the amplitude is 4. But be careful, a is not positive 4. Notice that this cosine is increasing first, which tells me that a is negative 4. So now we can write our function. A is negative 4, b was 3, and c was pi over 2. So we can determine a unique function if we make the assumptions. We're going to be told whether it's a sine or cosine. In this case, it's a cosine. We're going to be told b is positive, and we're going to be given 5 quarter points of one cycle that associates and corresponds to the quarter points, in this case for y equal cosine x, for x between 0 and 2 pi. Practice working these examples until you've mastered the skills and concepts involved.